Here we shall discuss about the type of partitional clustering that we call that one as a k-means clustering. So what is k-means clustering? K-means clustering is an iterative algorithm so that is used to partition a data set into k distinct non-overlapping clusters. So in 2D space, if I have to take like two data points, this is often used to group the data points that are geometrically close to each other, such as classifying objects by width and height. So the main two concepts that are involved in k-means clustering are one is the Euclidean distance, which is calculated by d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So where x1 y1 and the x2 y2 are the two different data points, and the second one is the centroid update. So if I have to find out the centroid of x comma y, so that is summation of xi divided by n comma summation of the yi points, that is divided by n. So these two things will get more clarity when we consider one example. So if you take one example here, that is we have the four data points here, p1 1 comma 1, p2 2 comma 1, p3 4 comma 3, and p4 5 comma 4. So if a question is asked to find the final two clusters where k is equal to 2 by using k-means clustering. So since here k is equal to 2 is given, so let's actually select two initial centroids. So as I said earlier, we have that k is equal to 2. So that means actually we have to consider two centroids. This k usually it will be given in the question paper or in the problem, that is k value. So when k is equal to 2, we have to consider two centroids. So let us consider two centroids. Let me take C1 centroid 1, and that let me take it as that can be taken in any random way. So let me take the first two as the two centroids. C1 is C1 given by 1 comma 1, and C2 given by 2 comma 1. So let us construct the first table. So let us actually do the first iteration. So iteration 1. So the first thing that we have to consider is different data points. The point, what are the different data points that we have? So p1 which is 1 comma 1, p2 which is 2 comma 1, and p3 which is 4 comma 3, and p4 which is 5 comma 4. So this is related to the data points. Next one, we have to find distance to C1 centroid 1, that is we have to consider this one as the that is sorry, so C1 as the 1 comma 1, so that we have taken. And next one is distance to C2. So C2 is basically 2 comma 1. Last one actually, which one we are going to group, let me take that one as assignment. Okay, our cluster. So it is based on the Euclidean distance, that is square root of 1 minus 1 whole square plus square root of 1 minus 1 whole square, which is given to be 0. So second one, what we have this one, the distance of again we have 2 minus 1 whole square plus 1 minus 1 whole square. So this 2 minus 1, 1 minus 1. So again this value what we have is 1. Again we have this 4 minus 1 whole square plus 3 minus 1 whole square. So this one is what we have here is 3.6. This you can just compute actually. 4 minus 1 3 square plus 3 minus 1 2 square, so it is 9 plus 4. So again we have square root of 5 minus 1 whole square plus we have 4 minus 1 whole square. So this is 5 minus 1 4 square 16 plus 9 25, square root of 25 is 5. So similarly actually you can just find out this one. So this is 1 minus 2. So 1 minus 2 square, 1 minus 2 whole square plus 1 minus 1 whole square, which is this is square root of 1, that is 1. So similarly we have 2 minus 2 whole square plus 1 minus 1 whole square, which is 2 minus 2 0, 1 minus 1 0, so square root of 0 is 0. So similarly 4 minus 2 whole square plus 3 minus 1 whole square, which is probably 4 minus 2 is 2 square 4 plus 2 square 4, square root of 4, so somewhere actually we get it is 2.8 something. So again we have this x2 minus x1 whole square plus y2 minus y1 whole square, that is 5 minus 2 whole square plus 4 minus 1 whole square, which is 3 square 9 plus 3 square 9, so that is square root of 18. So roughly I think we'll get this one as 4.2. So now the yeah, so this data point which is closer, so the lesser of these two things that we have to consider. So the lesser of these two things, so which actual cluster assignment that we have to do. So first if we consider this one, yeah, so sorry for the interruption. So basically first as I was mentioning, so in the iteration 1 now we have already calculated the distance from every point to the both the centroids, that is centroid C1 and centroid C2. So now we have to assign the point to the closest one. So whether this point belongs that is closer to the centroid C1 or the closest to the centroid C2, that you can actually find out from the Euclidean distance. Since actually Euclidean distance of this point to the C1 is lesser than the Euclidean distance of this point to the centroid C2, we just assign the cluster 1. Okay, so this we have this point is closer to the centroid 1, so that is we assign this one as a cluster 1. So next one is this data point is closer to the centroid C2, so that actually we'll find this one as cluster 2. So similarly actually we can see here 3.6 is greater than 2.8, so this also we will assign cluster 2. And here okay, this also we assign cluster 2 because 4.2 is less than 5 here, and this data point is closer to the centroid C2, so we assign this data point to the cluster 2. So similarly you can just observe this one. Now what is the next one? As I mentioned here, we have to update the, first we found out the Euclidean distance, next we have to update the centroid here. So how do you update the centroids? We have to find out the mean here. So what is the mean that we have it here? Okay, yeah. So the mean is, so the first one, since actually now let me write it, what is the new C1? So new C1, that is new, let me write this one as a subscript. So new C1. So since cluster 1 has only P1, that is 1 comma 1, you can see here, right? So in the cluster 1 there is only one data point, that is P1 1 comma 1. So P1 1 comma 1. So what is the average that we have it here? So average anyhow, since there is only 1 comma 1, the new cluster C1 that will be 1 comma 1 only, isn't it? So next one, the what will be the new C2? So cluster 2 has 3 data points, that is P2 and 2 comma 1, P3 4 comma 3, and P4 5 comma 4. Now we have to find the mean of this one. So x average is equal to, what is this one? So 2 plus 4 plus 5. So 2 plus 4 plus 5 divided by number of data points, that is 3. So that basically we have 2 plus 4 6 plus 5 11 by 3, that we have 3.67. Similarly, y average is given by, we have 1 plus 3 plus 4. So 1 plus 3 plus 4 divided by 3, 4 plus 4 8 by 3, we have 2.67. So the new C2, so what will be the new C2? So new C2 is given by 3.67 comma 2.67. So this is a new C2. So new C1 is 1 comma 1, whereas new C2 is 3.67 comma 2.67. So next one we have to update here. So what is the thing that we have to do? This is the iteration 2. So iteration 2, again you have to consider the same points, some data points, that is P1 1 comma 1, P2 we have 2 comma 1, P3 we have 4 comma 3, and P4 we have 5 comma 4. So let me write distance to C1. So what is the new C1? Okay, new C1 is same as the old C1, that is 1 comma 1. Now this is okay, so let me, yeah, sorry, distance to C1 1 comma 1. So next one, distance to C2, that is 3.67 comma, let me take out this one, 3.67 comma 2.67. So finally we have the assignment. Okay, so here again similar same formula, that is square root of this formula, right? The equivalent distance that you have to find, square root of x2 minus x1 whole square plus y2 minus y1 whole square. So let me write directly. So square root of 1 minus 1 whole square plus 1 minus 1 whole square, what we have is this one 0. Let me fill it here. So this is 0, this is 1, this is 3.6, and this is 5. Okay, and similarly what we have is 3.149, 2.362, this is 0.467, this is 1.881. These all values are computed by the equivalent distance between these various points. So that is how we just compute here, again this one with this one, right? Similarly what we did in the iteration 1. So finally, actually the most important thing is that what actually the cluster that we're going to assign. Now just see, actually 0 is now it is less than 3.149. That's why we have to assign this one is the cluster 1. So still P1 actually belongs to cluster 1, whereas if you see here, this 1 is less than 2.362. So 1 is less than 2.362. What we have is cluster, now it is cluster 1. So earlier if you just see here, this 2 1 actually belonged to cluster 2, whereas now it got changed here. So let me, okay, this is cluster 1 here. So earlier it was cluster 2, but here this is 0.4767 is this is less than 3.6. So now actually same, it is cluster 2. This 1.81 is less than 0.5. So again it is same, that is cluster 2. So in the iteration 2, so what we have to observe is this P2, the data point has changed. Assignment of the P2, now it got changed to cluster 1. So earlier it was cluster 2. Since iteration 2, this assignment is not same as the iteration 1. There is a change, right? So here earlier it was cluster 2, now it is cluster 1. So now we have to repeat again, we have to do the iteration 3. The same thing that we have to do it here. So now what do we have to do? Now again, so you have to find the centroids here. So let me actually take again new centroid for iteration. Okay, let me actually write it here only. So now what will be the new C1? So again new C1. So new C1, now actually there are two data points. So what are those two data points? That is what are the two data points that we have to consider? Mean of P1 and P2. So earlier there was only one, that is P1. Now we have P1 and P2. Similarly, new C2, that is mean of P3 comma P4, these two. So these two data points that we have to consider. So what are these two? 1 comma 1 and 2 comma, sorry, 2 comma 1. So here it is 4 comma 3 and 5 comma 4. So what will be C1 here? So C1 will be the new C1 for the third iteration. Okay. So for the third iteration, new C1 will be 1 plus 2, 3. This is 1 plus 2, 3 by 2, because only two cases that we have here. So 3 by 2 is 1.5. Similarly, 1 plus 1, 2 by 2 is 1. So it is 1.5 comma 1. Whereas mean of P through P4, how many data points are there here? Two data points. You have to consider 4 plus 5, 9 by 2, that is 4.5, and 3 plus 4, 7 by 2 is 3.5. So these are the new two data points that we, sorry, centroids we have. That is new C1 is 1.5 comma 1 and C2 is 4.5 comma 3.5. So next again we have to construct the third iteration table. Let me write it here. We keep on doing this one until the assignments, the cluster assignment remains same with the earlier iteration table. So for that one again we have to consider that is point p1 1 comma 1, p2 we have 2 comma 1, we have p3 we have 4 comma 3, and p4 we have 5 comma 4. And again now we have to write distance to C1. Okay, let me write the subscript here. So distance to C1, now see it is a new centroid, that is 1.5 comma 1. Similarly, distance to C2, we have a 4.5 comma 3.5. Now the assignment table, sorry, assignment column. Okay, so similarly we need to compute for all the cases here. Yeah, so first one, square root of 1 minus 1.5 whole square plus 1 minus 1 whole square, that is square root of 0.25, you get it. So that is what I'm sorry, actually the square root of 1 minus 1.5 is 0.5 square, and 1 minus 1 is 0. So square root of 0.5 square is 0.5. Okay, and this is similarly, it is, yeah, here also we get 0.5. Whereas this already computed, so let me write the values 3.2, and this is 4.6. You can just cross verify with the values here. And similarly you have it is 4.3, and this is 3.5, and this is zero point 0.7, and this is 0.7. Same way, the square root of these two data points that you have to consider, the Euclidean distance between these two data points. So Euclidean distance formula is square root of, which remains same, x2 minus x1 whole square plus y2 minus y1 whole square. So now we have to assign it, right? This is important step. So now 0.5 again less than 1.4.3. So this remains same thing, cluster 1, 0.5 less than 3.5. So this is also cluster 1. 0.7 less than 3.2. So yes, it is cluster 2. 0.7 less than 4.6. Again, cluster 2. So now we can just see this one. So this assignment is same as this assignment, right? So cluster 1, cluster 1, cluster 2, cluster 2. So all the data points that we got it. So finally, uh, final cluster. So what is the final cluster that we have to do? That is, so cluster 1. So what all things are there in cluster 1? Two data points, that is p1, that is 1 comma 1. Then I have the p2, which is 2 comma 1. So these two clusters, sorry, very sorry, these two data points, okay, these two data points belong to cluster 1. And which two data points belong to cluster 2? These two data points belong to cluster 2, that is 4 comma 3, and you have 5 comma 4. Okay, so in this way we have to find we have to group the data points into particular cluster by using k-means clustering. So the idea is the key points are find, you have to find out the equivalent distance and you assign it. Then second point is finding out the average, so that you find out the new centroid. And finally you see that actually the assignment in the new iteration table is same as the assignment in the previous iteration table. If that is same, then stop, then you can stop the iteration. If it is not set, then you keep on doing the iteration, keep on finding the new centroid and keep on repeating the process until the both the iteration tables are same. That is the new iteration table, which is same as the previous iteration table. So finally you have to write the data points which belong to any particular cluster, like this. Two data points belong to cluster 1, these two data points belong to cluster 2. Okay, hope all of you guys understood the k-means clustering problem and how to solve the any example using k-means clustering. Thank you.